Good morning. Myself Prabha Ranche, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the topic name is steady state errors from the unit 2, that is time response analysis. From the subject name is linear control systems. Yeah, let us discuss. First, let us understand why steady state error is important in real life. Imagine a drone trying to hover at a fixed position. Even if it's controlled, it may slightly drift away from its target. This small difference between the desired position and actual position is called steady state error. Even a small error can lead to inefficiency, inaccuracy, and sometimes the overall system is failure. So, minimizing this error is very important in engineering system. Now, let us define steady state error. The steady state error is the difference between the desired output and the actual output as time approaches infinity. In simple word, it is the final error remaining after the system has settled. An important point to remember is that the type of system based on number of integrators determines whether this error is zero, finite or infinite. And next, let us see how we can reduce steady state error. Here, there are three main methods. First, increase system type, which means by adding integrators, we improve tracking accuracy. And the second thing is adjust system gain. Increasing gain, improve error constant like KP, KV, KA. And the third thing is use integral control in PID controller. The item accumulates past errors and help eliminate steady state error. So these techniques help us design more accurate systems. Now let us do one small classroom activity. Here you can see your puzzle question in on your screen. Here you have to find the value for the question mark position. Next, let us see how to design a meet error requirement. First step is define error tolerance. For example, error should be less than 1%. And second step is select system and controller. Choose appropriate system type and include integral control if needed. And step 3 is calculate and tune. Find error constant and adjust system gain to meet specifications. This process ensures the system performs are required. After designing, we need to test system. We use different test input like step input, ramp input, parabolic input. Also we use the final value theorem to calculate the steady state error mathematically. This helps us predict system performance before implementation. And this slide shows how steady state error behaves for different systems. You can observe how the output deviates from the input depending on system type and input. The error may be zero, finite or infinite. This visualization help us clearly understand system behavior. Yeah, now let us check your understanding with a quiz. The first quiz is which theorem is commonly used to calculate steady state error? First option is initial value theorem, and second option is final value theorem, and third option is Laplace theorem, and fourth option is Fourier theorem. Which one is correct? Yes, option B is correct. That is final value theorem. And second quiz is what is mean by steady state error in a control system? First option is error during transient state. Second option is error at time t equal to 0, and third option is difference between input and output as time tends to infinite, and fourth option is maximum overshoot. Which one is correct? Yes, option C is correct. Difference between input and output as time tends to infinite. If you have any doubt, you can ask me through the comment. We will meet in next video. Thank you.